Hello, I'm glad to introduce our work ReSCOM today. This work focuses on improved communication learning in multi-agent systems. Communication among agents can enhance their understanding of the environment and then make better decisions, such as ensuring safer driving. However, there are still some challenges in communication within multi-agent systems. First, agents cannot always communicate with each other given the limited bandwidth. Besides, there are more challenges in achieving rapid mutual understanding. For example, in autonomous driving, the system only allows a response time of a few milliseconds. Therefore, agents are expected to develop an efficient way to communicate while learning, which we call it as learn to communicate. Learn to communicate has shown a great performance in enhancing understanding accuracy and speed, while also reduce bandwidth usage. Learning to communicate includes basic communication tasks and advanced communication strategies. The former require learning how to communicate, including encoding environmental information into messages and understanding these messages. It's quite similar to the process of how we will learn language. The next level is advanced communication strategies, such as learning when and with whom to communicate. Current learn-to-communicate strategies training all the components at once, integrated with original tasks, such as multi-agent reinforcement learning. However, this approach comes with some issues. From our previous work, we can see that the strategy learned by the agent at the first stage is to avoid communication. This is because agent cannot understand the messages and not only process the cost of communication. Avoiding communication makes it harder to learn basic communication tasks, and then impact the original learning process and reduce the learning efficiency. In this paper, our insight is to decompose learning to communicate and allow agents to shift their learning focus from easier to harder tasks. To achieve this, we propose ReSCOM, which includes a reward shift curriculums for focus shifting. In the early stage, ReSCOM focuses more on the overall system performance, helping agents quickly learn how to communicate as a basic communication task. As the training process, ReSCOM gradually shifts its focus to the advanced communication strategies, guiding agents to learn when to communicate. The core of ReSCOM lies in the design of reward guidance curriculum scheduler. In the simple terms, by setting communication cost weights in the reward function, the agent focus can be adjusted. As the cost weights increase from 0 to 1, agents gradually shift their focus from basic communication tasks to advanced ones. But how to set costs is another problem. In this paper, we explore various methods for setting costs, including both decrease and continuous approaches. Please refer to our paper for the details. Finally, we evaluated ReSCOM across multiple environments, and the results demonstrate that it outperforms current learning to communicate methods. First, ReSCOM has less negative effects on original learning, providing smoother learning with less jitter. Second, ReSCOM enables agents to communicate with reduced bandwidth cost. And last, using autonomous driving as an example, ReSCOM reduced the collision rate by 50% and increased the error rate by 1.5 times. Well, let me wrap up. In this work, we proposed ReSCOM, an efficient joint learning framework that can combine learning to communicate with original learning tasks, for example, multi-agent reinforcement learning. While designing the reward shift curriculum, ReSCOM can shift the focus from basic communication tasks to advanced communication strategy learning. Our contribution includes ReSCOM can reduce learn-to-communicate's negative impact on original task learning, and it can offer smoother learning with less performance jitter. Finally, it can avoid useless communication and save bandwidth. Thank you for listening.